Everyone. We are going to discuss on the topic electrochemistry. So this involves the introduction, electrode potential, types of electrodes, and reference electrodes. When a metal rod is dipped in its salt solution, that is called as an electrolyte, the metal atom tends to lose electron or accept electrons. When the loss of electron will take place, the process is called as oxidation, and the gain of electron will take place. It is said to be reduction. The process of oxidation or reduction depends on the nature of the metal. During this process, there develops a potential between the metal atom and its corresponding ion is called as electrode potential. So, electrode potential is a measure of tendency of a metallic electrode to lose or gain electrons when it is in contact with its own ion in solution. Reduction potential. The tendency of an electrode to gain electrons is called as a reduction potential, and its value is represented with a positive value. Similarly, the tendency of the electrode to lose the electron is said to be oxidized, is called as oxidation potential, and its value is mentioned with a negative value. The positive and negative value here indicates that whether the electron is gained or lost. But the magnitude of this x, that is the potential is same. It is a it is not change, but the positive and negative change is used to mention whether it undergo the oxidation or reduction. Then we will move over to standard electrode potential. So it is nothing but the tendency of the electrode to lose or gain electron when it is in contact with its own ion in solution of 1 m concentration at 25 degrees Celsius. So the standard electrode potential is constant at the given temperature. Then an electrochemical cell is made up of two electrodes in that one electrode undergo oxidation and other electrode undergo the reduction. Each electrode is dipped in its salt solution, and the two it is called as a half cell. The two half cell is connected by a salt bridge, and the potential difference between the metal and its salt solution is directly proportional to the single electrode potential, and it cannot be measured directly. We can able to measure the sum of the potential of the two electrodes, or it is nothing but the potential difference between the two electrodes, which is called as EMF, nothing but electromotive force. E cell is equal to E anode plus E cathode. That means anodic potential plus cathodic potential. This is an example for galvanic cell. A galvanic cell is a system in which spontaneous oxidation and reduction reaction occurs and generate electrical energy. Here in Daniel cell, two electrodes, one is zinc and copper, which is dipped in its salt solution zinc sulfate and copper sulfate, which is connected by a salt bridge. The circuit is connected by connecting with a voltmeter. How to represent this galvanic cell? The electrode showing oxidation reaction is anode and the other is a cathode. According to the IUPAC convention, the anode is always on the left hand side and cathode is on the right hand side. So it can be represented as that is the right hand side electrode and the ion in which it is contained, salt brick, left hand side solution, and then the metal ion. And the electrode on left is written by writing the metal first, then electrolyte, and the salt bridge is represented by the vertical line or the semicolon. Here you see that cell representation. This is also another way of writing the cell representation. Here in that, the ion concentration must be specified on the superscript. Electromotive force is called as EMF shortly. The flow of electricity from one electrode to another electrode in a galvanic cell indicates that the two electrodes have different potential. Suppose if there is no potential difference between the electrodes, there is no flow of current. When there is a potential difference, then only movement of electron, that is movement of current, will take place from higher potential to a lower potential. So that is why it is called a EMF. That is a electromotive force, which depends upon the temperature, nature of the reactant, and the concentration of the ions in solution. So mathematically, E cell is equal to E cathode plus E anode, or we can write it as E right minus E left. Thank you.